This is Ham College, episode 88 for April 30th, 2022. Ham College is brought to you by Icom. Field Day, ham radio's most popular event of the year, is just around the corner. Be a Field Day leader with Icom. Well, good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And it's good to be back for the April episode.
Yeah, what number is this?
This is episode number 88.
88. Wow.
Yeah. Do you remember what we talked about last month?
Nope. But I probably got it on a cheat sheet.
Okay. Maybe you don't.
Oh, yeah.
Yeah.
Diodes.
Well, that was short and sweet.
Yep, it was.
Well,
What are we going to talk about this time?
Well, this time around, we're going to talk about digital ICs, the families of digital ICs, gates, programmable logic devices, all kinds of neat stuff.
Going to talk about them and their families, so
Both.
that's pretty low right
Yep.
there.
We'll see. Before we get on into the show
It
here.
could be high. I don't know. It depends on the state of the bit.
Yeah. So what have you been up to?
Not a whole lot. Let's see. World Amateur Radio Day was the other day, and I actually missed out on it. I didn't get to do anything. Did you?
I turned on the radio, and
Well, you topped me because I didn't even get to turn mine on that day.
I booted up my hotspot, and I tried to connect with Amanda and Jeff over, I don't remember what mode I tried. I think it was probably D-Star.
Mm-hmm.
Anyway, my hotspot just wouldn't cooperate with me. I could hear fine, but I couldn't get a signal out. So,
Oh, man.
I got to redo the image on both
Oh, you
of
hadn't
them.
done yours yet?
Neither one of them, no. So I need to get on that. But let's see. Otherwise, I've been spending some time outdoors with some transmitter projects that have been kind of waiting till the weather got good. And the weather
got good.
I ran out of excuses, yeah.
Yeah.
Well, I had a couple of things we wanted to talk, sort of related to amateur radio exams and testing. The first one here is, well, this is interesting. On Wednesday, the FCC sent notice to all the VECs, again, asking them to refrain from sending any amateur radio exam session or license application files while the Commission works to resolve an issue with the Universal Licensing System Applications Filing System. Apparently, the ULS application filing system is not functioning properly, or wasn't last week. And then the FCC reported that the problem was resolved, and now they're saying, no, it's not resolved. Don't send us any applications. So, boy, that's a bummer, isn't it?
It is.
Yeah. Tuesday, April the 19th, is the day that the FCC application fees became effective. You remember the brouhaha about
I do.
that. Well, since they're effective now, apparently their website's busted and they can't take payments, and you're not getting a license.
Oh, wow.
Yeah. At least not till they get that straightened out again. They upgraded the systems, and they're just not working. So they've got to straighten that out. In the meantime, VECs don't send any applications, to them until they say go. In addition, any new call signs are not being issued, even if the applicant has paid the FCC fee. Some applicants are having issues paying and logging into the system, but the FCC is processing upgrade applications through the system without an issue because there's no fees required for those applications.
Remotely related to the one you just mentioned, but this is about the ARRL Youth Licensing Grant Program. The ARRL Youth Licensing Grant Program in effect since April 19, 2022, which is very recent. Anyway, it will cover one-time $35 application fee for new amateur radio license candidates younger than 18 years old for tests administered under the ARRL Volunteer Examiner Coordinator Program. The $35 Federal Communications Commission application fee will be reimbursed after the ARRL VEC. That's a lot of letters all in a row there. Receive the completed reimbursement form and after the new license has been issued. Reimbursement check will be mailed to the fee payer. Also, candidates younger than 18 would pay a reduced exam session fee of $5 to the ARRL VEC team at the time of the exam. The $5 fee is for all candidates under the age of 18, regardless of the exam level taken. Proof of under 18 status is required at the session. So that's good.
Yeah.
Makes it a little bit less of an obstacle for the younger people.
Yeah, that's a good thing.
Mm-hmm, definitely.
Well, what do you say we get on into the questions? And last time around, I don't remember who had the first question. I think I did.
Okay. Well, I guess I'll take it this time then.
Well, I'll give you your choice because you'll be saying it was rigged if I don't. You want to take the
really
first
matter.
one?
Yeah, I'll take the first one.
Okay.
I don't really care. The buzzer's going to happen either way.
True. All right, here's...
And I didn't study like usual, so there you go.
Well, I didn't really study so much either. Actually, I put in these questions 2 or 3 weeks ago, and I haven't looked at them since. What is the function of hysteresis in a capacitor? Is it
Can
A?
I change my mind?
No, it's too late now. A, to prevent input noise from causing unstable output signals.
B, to allow the comparator to be used with an AC input signals.
C, to cause the output to change states continually.
Or D, to increase the sensitivity. What is the function of hysteresis? I guess that's how you pronounce that in a comparator. Prevent input noise. Allow the comparator to be used with AC. I don't really know the answer to this one, so I'm going to do, this is going to be a WAG answer. Prevent input noise from causing unstable output signal. Probably help if I knew what hysteresis is. I'm going to go with A. I'm just guessing. To prevent input noise from causing unstable output signal, which is probably not right.
Well, that's a pretty good guess. That's the same one everybody else in the chat room has.
Oh.
So, yeah, you got that one.
Oh, wow. That was a good old guess, too, because I had no idea.
Really?
So what is hysteresis?
Hysteresis is what it's doing, like on a comparator. I guess I shouldn't say what a comparator is. Or should I? Yeah, I guess I can. I've got it marked down there that I can say what it is. Now, a comparator is a device that compares two voltages or currents and outputs a digital signal indicating which is larger. It has two analog input terminals and one binary digital output. Is binary even allowed anymore? I think there's people trying to cancel that. Anyway, a comparator consists of specialized high-gain differential amplifier. They are commonly used in devices that measure and digitize analog signals such as analog-to-digital converters, as well as relaxation oscillators. Small voltage fluctuations due to noise they're always present on the input, can cause undesirable rapid changes between the two output states when the input voltage difference is near zero. To prevent this output oscillation, a small hysteresis of a few millivolts is integrated into many modern comparators. So there you go. Exactly what
That's
you
what
wanted to know.
Yeah, that's exactly what I thought it was.
Yep. All right.
All right. What happens when the level of a comparator's input signal crosses the threshold? A, the IC input can be damaged.
B, the comparator changes its output state.
C, the comparator enters latch up.
Or D, the feedback loop becomes unstable. What happens when the level of a comparator's input signal crosses the threshold? Let's see, the IC input can be damaged. No, we're not saying it's crossing the maximum, we're just saying it's crossing the threshold. B, the comparator changes its output state. I believe that's it, but let's see what the others are. C, the comparator enters latch up. Now, I don't think there is a thing called latch up in a comparator. Or D, the feedback loop becomes unstable. No, it's B, the comparator changes its output state once the input crosses the threshold. That's what I'm going with. The chat room looks like
That's pretty much unanimous.
Yeah. Okay. And it is. It's B.
Here, I'll give you that.
Okay. Well, one more for you here. What is tri-state logic? A, logic devices with 0, 1, and high impedance output states.
B, logic devices that utilize ternary math.
C, low power logic devices designed to operate at 3 volts.
Or D, proprietary logic devices manufactured by tri-state devices. Sounds kind of plausible, but I'm going to skip that one.
Yeah.
Tri-state logic. Device is designed to operate at 3 volts. I don't think tri-state means 3 volts. Logic devices utilize binary math. It's got to be A. Logic devices with 0, 1, and high impedance output states.
Okay. I'm going to agree with you, as does the chat room, except for Spike. He wants to know, well, no, that's John. Is ternary really a word?
That's a good question.
Jury's out on that one.
It is there.
Yeah, we're all thinking A. So there you go. You knew more of this than you thought you did.
Well, that would make sense because it's tri-state logic. I mean, you're pretty much the only one that makes any sense up there.
Yeah. Yeah.
Which of the following is an advantage of bi-CMOS logic? A, its simplicity results in much less expensive devices than standard CMOS.
B, it's immune to electrostatic damage.
C, it has high input impedance of CMOS and the low output impedance of bipolar transistors.
Or D, all of these choices are correct. Okay. Which of the following is an advantage of bi-CMOS logic? Its simplicity results in much less expensive devices than standard CMOS. I don't think so. It's immune to electrostatic damage. Maybe. So I know it's not D, all of these choices, because I already ruled out A. C, it has a high input impedance of CMOS and low output impedance of bipolar transistors. I'm going to go with that. I believe the answer is C. Chat room, smart chat room in there tonight, or else we're all pretty stupid. They all said it was C.
You didn't just call the whole audience.
Well, myself included. So. And it is. See, they're all geniuses.
How about that?
Let's see. I think I had something to say about that. Bipolar transistors offer high speed, high gain, and low output impedances with relatively high power consumption. CMOS technology offers high input resistance and is excellent for constructing large numbers of low-power logic gates. BiCMOS is aimed at mixed signal devices such as ADCs and complete software radio systems on a chip that need amplifiers and analog power management circuits on a chip, as well as logic gates, and has some advantages in providing digital interfaces. And that's all I got to say about that.
And that's enough.
Yeah. Just enough.
Just the right amount.
All right. Well, I have another question for you. I've been wondering, what is the advantage of CMOS logic over TTL devices? A, differential output capability.
B, lower distortion.
C, immune to damage from static discharge.
Or D, lower power consumption. Advantage of CMOS logic devices over TTL devices. Different output. I think I'm going with D. I know CMOS devices are typically pretty low power consumption.
Mm-hmm.
I'm going to go with D.
Okay. That's what the chat room's saying. That's what I'm saying. That's pretty much just what I said when I was reading that a minute ago.
I know camera chips, when they went to CMOS technology, it really helped the battery life. But it also helped, there was a static element with it too, and it reduced that. But I'm thinking the answer is D.
Yeah. No, actually the static thing got worse.
Really?
Yeah. CMOS is a lot more prone to static discharge damage than TTL, but lower power consumption.
Why do CMOS digital integrated circuits have high immunity to noise on the input signal or power supply? A, large bypass capacitance is inherent.
B, the input switching threshold is about 2 times the power supply voltage.
C, input switching threshold is about 1/2 the power supply voltage.
Or D, bandwidth is very limited. Why do CMOS digital integrated circuits have high immunity to noise on the input signal or power supply? Well, it's not that the bandwidth is very limited, so we can scratch out D. Large bypass capacitance is inherent. I don't believe that has anything to do with it. So we're down to B or C. The input switching threshold is about 2 times the power supply voltage. I don't think that's even possible.
2 times?
Yeah. How could you have a circuit that uses 2 times your highest voltage?
It'd be pretty inefficient if it did, wouldn't it?
So I'm going to go with C. The input switching threshold is about 1/2 the power supply voltage. I don't know. This one could get me here. Well,
I think that's probably right. At least from
all the
at least
geniuses.
that's one thing I would have guessed anyway.
All the geniuses in the chat room are saying C. Okay. About 1/2 the power supply voltage.
Interesting.
Yep. It couldn't be 2 times it because That means you wouldn't have 2 times it available in the circuit to use in the first place.
Uh-huh.
So, all right.
Interesting. I keep saying that, but it actually is. It kind of makes you think about some of that stuff.
Yeah.
Some stuff I don't ever think about. Like I told you before, I knew the topic when it came in, but these logic ICs and stuff like that, I've never dealt with the. I mean, I do logic in my programming at work all day, every day, but it's kind of different. The end result's similar, but the way you get there is very, very different.
Yeah. Well, that's about half of the questions.
What about the other half?
Well, why don't we take a break? I know how, well, not that these were really that tough, but why don't we take a break anyway? Be a Field Day leader. Field Day is ham radio's most popular event. On June 26th and 27th, more than 40,000 North American hams come together to operate remotely. Connect with nature. Connect with friends. With a powerful and high-quality Icom radio, easily cut through pileups to get that contesting edge. Our popular IC705 portable, IC7300, and IC7610 SDR transceivers are the clear choice for DXers and contesters across the globe. The IC705 is the perfect transceiver for hams who enjoy both the great indoors and outdoors on Field Day. Features and functionalities at the tips of your fingers in a portable package covering HF 6 meters, 2 meters, and 70 centimeters. And it weighs in at just under 2 pounds. 4.3-inch color touchscreen with live band scope and waterfall. 5 watts with BP 272, 10 watts with external 13.8 volt DC. Single sideband CW, AM, FM, as well as full D-Star functions. The IC7300 is a high-performance innovative HF transceiver with a compact design that will far exceed your expectations. This is a radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. The IC7610 is the SDR every ham wants. This high-performance SDR has the ability to pick out faint signals in the presence of stronger adjacent signals. The Icom IC7610 is a direct sampling software-defined radio that has changed the world's definition of an SDR transceiver. RF direct sampling, 110 dB RMDR, independent dual receivers, and dual digicell. For more information on these and all the great Icom radios, visit icomamerica.com/amateur. What do you say we give away something?
Hey, look what I found. How about this?
Oh, an Icom Ham Crew t-shirt?
Yep. And what is it we always say? You'll look just as good when you're leaving the ham fest as you do when you get there.
Yep.
So, why don't we just give him a whole swag kit? Whatever Jesse's got, he usually puts a bunch of extra stuff in the bag for the winner.
Yeah.
And who is the winner?
Well, I had a drawing right before the show tonight. And the lucky winner this month, we got an email that says, "Hi, George and Tommy. The symbol in position 1 on figure E6-2 is a voltage variable capacitor symbol according to the ARRL 2021 edition handbook. Hope this helps. Very respectfully, Earl Gray, KD7SJT." And Earl, you weren't even entering the contest tonight, my friend, and you won.
Awesome.
Because
Congratulations.
he sent it to the contest address, and he was the random number we
He's got
picked.
a cool name. I like your T.
Yeah. Good stuff.
Yeah.
So congratulations, Earl. You'll be hearing from Icom, and they'll get that in the mail to you very soon. So we have a few more questions to go here yet. By the way, if somebody, we mentioned the email, how would you win this?
Oh, it's easy. That's basically all you got to have is an email address. Send an email to hamcollege@AmateurLogic.TV, and you'll be entered into the drawing. If you don't win, be sure to enter the next month so you can be in the drawing because it gets cleared out each time.
Mm-hmm.
So, and shortly he'll delete all the emails in there and we'll start over fresh.
Well, I already did right before
Well, there
the
you
show
go.
started.
So send them in now.
Yeah.
And next month we'll do another drawing, same thing.
Mm-hmm. AmateurLogic.TV. And you can give us you can give us the answer to questions we aren't able to answer, or we didn't.
Yeah.
Or you can say hi, or you can just say your name, and that's what some people do.
That's all you really got to have.
Yeah.
A name and an email address.
All right.
And a shirt size, but you don't have to give that to us. Icom will get it from you when they contact you to send you your prize.
Yep. Well, back into the questions here. What best describes a pull-up or pull-down resistor? A resistor in a keying circuit used to reduce key clicks.
B, a resistor connected to the positive or negative supply line used to establish a voltage when an input or output is an open circuit.
C, a resistor that ensures that an oscillator frequency does not drift.
Or D, a resistor connected to an op-amp output that prevents signals from exceeding the power supply voltage. This one I actually have a little bit of experience with. What best describes a pull-up or pull-down resistor? And I'm going to go straight for the kill here, and I'm going to say that it is B, a resistor connected to the positive or negative supply line used to establish a voltage when an input or output is an open circuit. So we dealt with those on those I/O cards quite a number of times in the previous project we were doing for years.
Yep.
So I feel pretty confident that it's B.
All right. I'm going to agree with you, and the chat room does as well. And it is B. So why don't we just talk briefly about pull-up and pull-down resistors.
Okay.
Paul says it's a resistor that holds your pants up. So no, Paul.
Well, you don't want to pull down resistor then.
No, you
Not
don't.
in public.
No. It's a pull-up or pull-down depending on which side of the supply voltage it goes to. A pull-up resistor may be 10, 20 k ohms or so connected to your plus DC voltage line. And that just holds that logic in the positive state or at a 1 because you're expecting a low to activate it. And that way any noise that's present there doesn't toggle it back and forth and give you the wrong result. A pull-down resistor, it's right the opposite. You're expecting a high to come in, so you want that circuit to normally be low. So you just put a resistor in there to kind of pull it low.
So what happens if you don't put a resistor on there?
If you don't put a resistor on there, well, then your circuit can kind of, it can give you garbage.
Could float.
It could float, yeah, well, and vary. You know, you might be sitting there waiting on a high to come in, and all of a sudden the circuit or the gate thinks it got a high, when actually it was maybe just a little bit of noise or something, on the power supply line.
Mm-hmm.
So, if you don't use pull-up or pull-down resistors, your logic circuits, good chance they're not going to work right. Now, some devices, like I think it's the Arduinos now, have pull-up and pull-down resistors built into them, and you can use a programming command to tell it which way it needs to go. But
yeah, that's pretty nice.
Yeah. That's what a pull-up and a pull-down resistor are. Let's see, next question here, and I guess this is one I'm going to have to answer.
All right. Oh, it's a tough one. In figure E6-3, what is the schematic symbol for a NAND gate? A1,
B2,
C3,
or D4? All right. I'm waiting to see what the chat room says here. Well, I guess they would like a clue, huh?
Yeah, they're not saying anything.
Okay. Which is the schematic symbol for a NAND gate? A, B, C, or D?
Yeah, I'm probably going to get the buzzer when my turn comes around for these.
1, 2, 3, or 4. So if you say 5 or 6, you're definitely wrong. And I said a NAND gate. That means a negative AND gate. Number 1 is an AND gate. Number 2 is a NAND gate, because that little circle there on the output means that it's inverting. It's an AND gate, but it inverts, so it's a negative AND gate or NAND gate. So I'm going to go with 2. I believe that is B, and that's correct. It is B. What was the chat room saying?
Lots of stuff.
Yeah.
12.
Yep.
B. Most of them got 2 and B.
Yep. Okay. There you go. What is a programmable logic device, a PLD? Is it A logic circuit that can be modified during use?
B. A programmable collection of logic gates and circuits in a single integrated circuit? Thanks.
C. Programmable equipment used for testing digital logic integrated circuits.
Or D. A type of transistor whose gain can be changed by digital logic circuits. What is a programmable logic device, or PLD? It's going to be B, I think. A programmable collection of logic gates and circuits in a single integrated circuit.
Okay.
It is a programmable logic device after all. Everybody got in there. B's.
Yep, most of them are B's. Yep. And it is. PLD. You know, I've been wanting to play with one of those, but I hadn't.
Yeah.
Yeah.
Might be an interesting amateur logic segment.
Oh, no, I don't think
so?
my early experiences I would probably want to share with anyone. They won't be very pretty, or they may not work. So, but yeah, neat devices. Bunch of logic gates and circuits in a single IC, and you just program it as to what it needs to do.
Cool.
Oh, we're back to this again, huh?
I'm glad, because I don't know the symbols too well. In figure E6-3, what is the schematic signal for an NOR gate or NOR gate? A1,
B2,
C3,
or D4? What's the schematic symbol for a NOR gate? Well, let's see. Here we go right here. Well, we've already talked about 1 and 2.
Oh, I think I know which one it is.
So 3 is an OR gate. Okay, so that must mean
It's got to be 4.
it's got to be 4. That's a negative OR gate or a NOR gate.
Awesome.
Number D.
D.
What did the chat room say? Yeah, they
Pretty much got it.
Yep.
You sunk Mike's battleship.
So do you know what a NOR gate does?
No. Well, it's a negative OR. But no, not exactly.
Do you know what an OR gate does?
Well, I'm assuming it's kind of like an OR function in programming.
Yeah, and what does that do?
Well, it evaluates either this or this and gives you a true. So I guess it would give you a false. Is that what it does?
That's basically it. If you were expecting a high and you got a high on one or the other, you
depending on
get
how
a
you
low.
had it.
Just to make this fair, in figure E6-3, what is the schematic symbol for the NOT operation inverter? Is it A2,
B4,
C5,
D6.
bingo.
Huh? Oh. Got you.
All right. I made this too easy because I've already said what most of them are on there.
And we were looking for a knot?
Yep.
Okay, I'm going with 5.
Yeah. Yeah, I'm going to agree with you, Tommy. It is 5, which is C.
Yeah.
Yep.
So those weren't as bad as I thought they would be.
Yeah. And that's commonly called an inverter. If you were going out to buy a integrated circuit, you wouldn't buy a NOT gate. You'd buy an inverter. It's the same thing as a NOT gate, and all it does is reverse the logic. If you got a 1 coming in, it gives a 0 out. 0 in gives a 1 out.
It's interesting.
Yeah. Just like programming,
Yeah, I was just trying to thinking of what you might use some of that stuff for.
Everything.
Practical circuits.
Yeah. Any and everything. Before we had the programmable stuff, that's what we use for everything. After cubes, we started getting integrated circuits. You can do the same thing with transistors.
Oh, yeah.
Yeah. So, well, congratulations. That is all of the questions on tonight's subject.
Wow, and not a single buzzer.
Not a single buzzer.
I would have bet money when I came in here that there was going to be some buzzer action.
Yeah, I didn't think so. I figured we'd do okay on these. So, we got a few minutes here. What do you say we throw a hook in the water right quick and come back?
Okay.
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau.
Roughly, here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through. So we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder. You can use WD-40. You can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet. Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one. So I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
We couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here.
We're still waiting.
Yeah, that's going to be a blooper right there if I actually do it.
Well, we got through those questions pretty quick tonight. I don't know if I wish. If I was taking the exam, I would wish they were all as easy as they were tonight. I had to take the exam again, but yeah, relatively easy questions compared to a lot in recent episodes.
Yeah, we went through a spell there for 2 or 3 months. They were really tough.
And there will be again.
Oh, I'm sure.
Yeah. It's probably easier. Well, I don't know. We'll just have to see. I don't know what's next. But we'll find out. Let's see what's going on in the chat room tonight.
I always want to do the Les Nessman thing. Let's turn to the news and spin my chair
Yeah?
around, but I'm afraid I'll knock something over if I do that.
You might.
Hurt
Yeah.
myself.
Well,
Arnie was hoping there was bloopers. He didn't see the show from the beginning.
you missed the best blooper, Arnie.
It was major.
Yeah. Yeah, kind of. But it'll be on the recorded version at the end. Always a big time in chat, eh? Yeah.
Yeah, the chat is fun. We hadn't said it in a while about missing half the fun if you're not in the chat, but it really is true. If you watch the live stream, you ought to go in there and join in on it.
Arnie's asking how many questions are left. That's a good question, Arnie.
Yeah.
Let's see. We were studying tonight. These were E6C. And this many.
So maybe a third of them left. I can't see too good.
No, it's
A little more than that.
little more than a third left. But we're past the halfway point. And I should just glance through here and see what's coming up. Let's just take one out of the blue here and see who can get it. I'm just going to grab something out of the middle here. Ooh. I can't do that to them. I better choose something somewhere else.
Don't scare them where they don't come back.
What type of wave does a Fourier analysis show to be made up of sine waves of a given fundamental frequency plus all its harmonics? Is it A, a sawtooth wave, B, a square wave, C, a sine wave, or D, a cosine wave? A Fourier analysis shows to be made up of what type of wave? Of sine waves of a given fundamental frequency plus all its harmonics. Oh, we're getting answers.
Yep.
Okay. And they are about as accurate as my answer would be on this one.
All over the place. Squirrel wave.
Yep. All over the squirrel wave. Is that what you said?
Yeah. Well, yeah, there's a squirrel wave in there. Could be that.
Well, should I give the answer?
Sure, why not?
It's a sawtooth wave. It's made up of sine waves of a fundamental frequency and all harmonics. The figure shows, well, I can't show you the figure, so there's the figure. That doesn't really help, does it?
Not a lot.
Yeah.
From that far.
A sawtooth wave is made up of sine waves of a fundamental frequency and all its harmonics.
You have to come back when that show airs to see the...
Yeah. It does kind of look like sawtooth, doesn't it?
Uh-huh.
Yeah. So, yeah, that'll be coming up pretty quick here.
Mental note, sawtooth wave. I'll remember that. Maybe.
No, well, I was going to say, should I choose another one, or maybe somebody will talk about something? Maybe we can get them to talk this way.
I had somebody contact me the other day, asked if I wanted to trade my oscilloscope for something. Even though I don't use it much, I just can't do that, man.
Really? No, you shouldn't get rid of your scope.
I'm not going to get rid of it. You don't need it much, but when you need it, it works. It's really good to have.
Yeah, Tom says number 6 looks like an alternate op-amp signal. There's number 6. Yeah, it does kind of look like an op-amp, except that rounded back. Are you guys going to do anything live from Dayton this year?
I'm not able to go, Jerry. I got some family things going on. I'm not going to be able to get away, so it's going to be the first one that I've missed that they've had in a long time. I hate it, but just can't really be helped.
Yeah.
You going to do anything live?
I am going. Email's going. Don't know about Mike. He hadn't said anything lately about it. And yes, I will be doing something live there, but you won't see me.
You won't see it?
No, I'm going up in advance of Hamvention. You know, the day before Hamvention every year they have Contest University. Well, it's an excellent resource if you want to know more about contesting and how to get your score up, and just all kinds of tips about how to set up your shack, what type of antennas to use, your technique during contesting. Well, Contest University is a place to learn that. And Icom has asked me to go up there. They're a sponsor of it, and I'm going to do the live stream for them this year. So you'll be able to watch Contest University live on Thursday the 19th, May the 19th. Well, I guess that's going to do it for tonight. Thanks, everyone, for joining us for this class. We'll be back at the end of May for the next Ham College, the middle of May for the next Amateur Logic. Join us then. And it's about time, well, if you're not in Canada, it's time to get out and do your antenna work. It's a little warm for that up there now.
Yeah.
According to Mike.
It's just about to come out of antenna season there.
Yep. You need to be getting on it quick before the leaves get on the trees too much. Now's a good opportunity. If you wait till the leaves are too full on there, it's a little bit tougher.
I actually need to take that advice and work on my own.
Yeah.
It's still up, but, you know, all those bad storms we've had, it kind of managed to work its way down a few rungs on the tree limbs there, so I need to get it back up in there a little higher.
Yeah, it's time to start thinking about field day plans as well. You know, it'll be here before you know it.
Yeah. I've been thinking about that.
Yeah, me too. All right, 7-3, everyone.
7-3, everybody. We'll see you, what was that, on Friday the 13th for Amateur Logic?
Yep. And let's just make it a whole swag prize. Let's.
You sure you want to do that?
Yeah. Why don't you say it?
B, a resistor connected to the positive or negative supply line used to establish a voltage when an input or output is an open circuit.
B, a resistor connected to the positive and negative supply line used to establish a voltage when an input or output is an open circuit.
That's what I just said.
I wasn't paying any attention to what we talking about. Yeah, I was.
I thought that sounded very familiar.
Yeah.
All right.
Yeah, everybody's already answered it now. We might as well just stop right here.
Should we start over?
No, let me try to recover.